Now let's discuss about area under the curves. Okay, from this chapter, there is always, like till now, every year there is one question in mains and one in advance, compulsory. Even in other exams, also, every exam, the area under the curves is there is one question compulsory. Now, like what is the ideal, like, or idea behind the question, like, or areas question is, there are few steps involved in it, like, and every step is equally important. Okay, what a typical question will be like this: you will be given curve 1, curve 2, let's say some lines, line 1, line 2, and we need to find out area under the curve. Okay, I'm just broadly spectating, like broadly giving you the question. There can be much more varieties of it. Okay, but majority will fall into this type of situations. Okay, so we need to find out area enclosed. Generally, we won't be given curve curve graphs. We will be given curve equations. So step 1 and in fact step 2 are together. We will be first plotting the graph. Sometimes for that we need intersection points, solving the curves. Sometimes we do it reverse. Solve the curves and plot the graph. Like we get both of them are mixed together. Okay. While we are solving the curves, we understand how the graph should be. That also can occur. These are the first two steps, and necessary. Most of the time they are necessary. Now step 3. What is step 3 is, we need to we need to identify the right region. The problem is, they don't give us like which region we have to plot. Area enclosed between these 4 equations. That's it. So we need, it's our job to identify which is the region. The enclosed by four curves or 3 curves in one line or 2 curves and 2 lines. Identify the right region. In fact, I should write right region. Now step 4 is another important step. Write the right integral. Write the right integral. Step 5, evaluate the integral. Okay, these are the 5 steps involved, and out of this, the toughest steps are these 2. Many good students also do mistake in this, writing the right integral and writing identifying the right region, because in a complicated questions, which region they ask is difficult to find. That is one. And once we find it out, there can be an error while you are writing your integral. It's not always integral f of x dx. That is not always correct. Okay, you will see the situations. Like you'll understand why integral f of x dx is not always correct. Why? Okay. Any doubt in the students? Please write it down. We will start with the questions. First, let us plot some curves. Okay, like this is the first one. Plot y equal to e raised to minus 1 by x square. Just to understand, like just to remind you a few things. Okay, that's all. Plot this. How do we plot y equal to e raised to minus 1 by x square? The graph is going to be, see, first of all, if I observe this, this is an even function. Correct, students? This is an even function because x replaced with minus x. And one more thing is, if I look at this, domain of this, domain is r minus 0. Correct? Yes or no? 0 by 8 is not defined.
Yes.
Now, one more thing is, limit extends to 0. Limit extends to 0. E raised to minus 1 by x square will be what? That's going to turn to e raised to minus infinity. Either 0 plus or 0 minus. You take any one of them, it doesn't matter. Limit extends to 0, e raised to minus 1 by x, minus 1 by x square will tend to e raised to minus infinity, which will tend to 0. Correct? Huh? It will tend to e raised to minus infinity. So that means when we are approaching 0, that is graph is at 0. Correct? Huh? When limit extending to infinity, limit extends to infinity, graph kidhar hai? That will be e raised to tending to 0, 1 by infinity. That is e raised to 0 is 1. So the graph is somewhat like this. Did you get the same, students?
Yes, sir.
Plot this graph. Plot xy plus 2x plus 4y equal to 8. Right. What we do is x in दोनों में से x common, y plus 2 आएगा. Now if I take 4 common, if I need y plus 2, what I should add? I
8.
should add a 8 such that it will be y plus 2. Such that x into y plus 2 plus 4 into y plus 2 equal to 16. So x plus 4 into y plus 2 equal to 16. This is like xy equal to 16. Now plot the curve. This is x equal to minus 4. This is y equal to 2. And xy equal to 16. So the curve is like this and like this. Clear, students? This is y equal, sorry, y equal to minus 2, right? Minus 2.
Yes, sir.
What I'll do is I'll move this above and plot. Y equal to minus 2 and plot it. The curve will be like this. It need not pass through origin. Origin is not satisfying. So it will be little like this. Yeah. Write it down for this. Now, in this, one thing that we want to, it's not an even function. One thing want to tell you is even not an even function. It's not an odd function either. Okay. So curve won't be symmetric about y-axis. Now, one more thing is, if I do limit extends to infinity, graph किधर रहेगा? 1 plus e power 1 by x graph. The domain is r plus 0, that is r minus 0. Except 0, we can substitute anything. Infinity डालेंगे, e power infinity is e power 1 by infinity, that is 0. E power 0 is 1. 1 by 1 plus 1, that is 1 by 2. Limit extends to minus infinity लेंगे क्या होता है? Exactly same thing. 1 by 1 plus 1, that is 1 by 2. Actually, plus 1 by x only, minus infinity डालेंगे. 1 by minus infinity also tending to 0, 1 plus 1. Now the problem comes where x equal to 0 पे क्या हो रहा है? Limit extends to 0 plus में. When I substitute 0 plus 1 by 1 plus e raised to 1 by x, it's going to give us limit extends to 0 plus 1 by, see this is going to tend to infinity, right? E raised to infinity is going to be infinity. So 1 by tending to infinity, this is 0. Limit extends to 0 minus ले लेंगे 1 by 1 plus e raised to 1 by x. This is e raised to minus infinity. E raised to minus infinity से खुद 0. That is 1 by 1 plus 0. ये 1 को tend करेगा. What is happening is, if you look at the graph of it, first plot, what's the matter? Plot y equal to half. And x पॉजिटिव पे क्या हो रहा है? 0 से स्टार्ट होता है, बिकॉज 0 प्लस पे 0 है, उधर से इट विल गो टिल हाफ. X negative side, it will start from 1 and उधर से it will go till half. This will be like this. Is it clear, students?
Yes, sir.
Right. Right. Area of a curvilinear trapezoid. First one we are interested in area with respect to x-axis. Okay, this is integral y dx. Area with respect to x-axis, which is integral y dx. Let me discuss. Now imagine you have a curve which is like this, f of x, completely above x-axis. And we are interested in finding out the area from A to B. Now area under this curve, this entire area we are interested in, area towards the x-axis from the curve. This is nothing but if I take a small rectangular portion, a minute rectangular portion of width dx, and here this is the y value, right? This is the y value of it. Correct? At that point, y dx is the area of that portion, and if I integrate from across A to B, that is my area. Yes or no? You've learned this concept in physics also, right? So area, you learned it as this is y equal to f of x graph. Area under the curve y equal to f of x from A to B is integral A to B f of x dx. Now, as I told you this already, not always this is the case. This is like one case where a curve is perfectly above x-axis. Now, second thing, when the curve is below x-axis, that means the curve is like this. And here also y equal to f of x only. It's not minus f of x. It's y equal to f of x only. Now, how do we find out this particular area? I will shade it a little differently. Now, the problem is this is below x-axis, right? So, if I try to write integral a to b f of x, that's going to be negative. I told you this in the indefinite integral chapter. Sorry, definite integral chapter. Correct? In such cases, how do I write this area? A to b. So, one thing I want to tell you, like, because, and I want to stress upon this point also. I told you writing the right integral, all these things, right? See, Jadata students, what they try to do is they see this and they say, ki, sir, if the area comes out negative, we'll apply modulus. That is okay with coordinate geometry because we don't have much issues there. Here, the problem is if you start doing that, there are some questions where you'll get the right answer. There are some questions you will not get the answer, not only the right answer, you will not get the answer in the options also. That means which will waste your time more than required. मतलब आपको गलत आंसर आया, आपका टाइम उतना ही वेस्ट हुआ, आपका टाइम और वेस्ट होगा if your answer is not in the options, and you will not get one more question because of that. Not only you lost those 5 marks. Do you understand me? So writing, always see, one important thing I want you to make sure is whenever you write your area at the integral stage, I'm not talking about calculation, at the integral stage, make sure you are taking the positive wala side area, matlab positive area into consideration. Matlab here area is going to be negative, so we will write our area under the area under curve is minus integral a to b f of x dx. Matlab when we are writing the integral itself, we are making sure we multiply with a minus, because see, आपको नेगेटिव आने वाला है, आपको पहले से ही पता है, आपको पॉजिटिव बना के ला रहा है. Do you understand this? At the integral stage itself, if you maintain this, then imagine at the end you got a negative answer. That means what is the sign? You did a mistake somewhere, because damn sure you wrote your integral properly. Okay. And one more thing, when there is a cluster of things, मतलब एक जगह पे positive है, दूसरा जगह पे negative है, positive, negative, positive, negative. होता रहता है. Like there are curves which are like that. In such cases also, when you keep your integral properly, your area will be proper. Okay, let me tell you the third case, you'll understand it better. Imagine your integral is like this. Matlab your curve is like this. Okay, this is your y equal to f of x. Possible. All trigonometric functions are like this. Many functions are like this. Cubic equations. There are a lot of functions like this, which will go to positive, come back to negative, go to positive. There are like that. Yes or no? Now, in such cases, if I ask you area under the curve from A to B, and this is some C, this is some D. Okay. Generally, how does it work? Imagine आपका मैंने areas का value दिया है. Like let's say, imagine इसका area value है 2 है, इसका area value 5 है, इसका area value है 6 है, or not 6. इसका area value is 3, let's say, or 2 only. If you see the right area equal to integral e to b f of x dx, you know what you are going to get a value. Can somebody tell me what is the value you are going to get?
1.
You're going to get 1. You're not going to get 2 plus 5 plus 2. Okay, and even if you apply modulus to it at the end, आपको 1 ही मिलने वाला है. 1 तो बिल्कुल ही गलत आंसर है. Do you understand? Why when 1 will come, you know? Integration के हिसाब से ये below x axis है, so that will give you calculation -2. And this second part वाला +5, third part वाला -2. Calculation 1 देगा. समझ में आ रहा है? So आपको area चाहिए. See, question is very clear in mains and advanced or any other exam, even boards also. Find the area enclosed between curve and the x axis. मतलब x axis और curve के बीच में जो भी area है आप ढूंढ लो. मतलब आप तीनों पोजीशंस को पॉजिटिव बना के ऐड करना चाहिए. करेक्ट ना? 2 + 5 + 2 9 आना चाहिए इस क्वेश्चन का. करेक्ट ना स्टूडेंट्स? सो व्हाट यू आर सपोज्ड टू राइट योर इंटीग्रल इन सच स्टेजेस व्हेन पॉजिटिव एंड नेगेटिव रहता है. आपको पहले से ग्राफ, दैट्स व्हाई ग्राफ इज नीडेड. पहला स्टेप, क्योंकि यू अंडरस्टैंड इट इज गोइंग बिलो और अबव. वंस यू नो इट, दिस पोर्शंस आर बिलो, that means they are negative region. You need to multiply for this minus with this for these portions, and you need to write the positive integral. So your area with respect to x-axis is going to be integral a to c minus f of x dx plus c to d f of x dx plus d to b minus f of x dx. Is it clear, students? Yes. That means at integral stage itself, you took care of the things. Okay. This habit is going to help you in all complicated problems. Not only this, like even board exam also, if your integral is wrong at this stage, at the starting step, it is wrong, they will not see next steps. They'll cancel it out. तब तक आपका आपने ग्राफ बनाया, उसका सॉल्विंग किया, उसका जितना मार्क्स है according to the evaluation sheet, they'll give you marks. Rest is cancelled. Is it clear, students?
Yes.
Yes. Please write down. Find area bounded by y equal to x mod sin x, x equal to 0, x equal to 2 pi. This is a question. How do we do it? Now there is a modulus. First, let us try to understand like how do we plot the graph. See, if I try to understand y equal to x mod sin x. See, whenever sin x is maximum, whenever sin x is mod sin x is maximum, mod sin x is 1, that then y equal to x is the line. That means first let us draw y equal to x line. That's not the answer, but it will touch y equal to x whenever sin x is maximum or mod sin x is maximum. Here. So at 0, and we are interested in 0, pi and 2 pi, right? Pi and 2 pi. Between 0 and pi, at 90 it will touch. Correct? No? At 90 it will touch. And at 370 it will touch. Correct? No? So the graph will be otherwise little below. correct? Or will it cross? Just a minute. Oh, no, it will be little below x, y equal to x line. Now, this is the area, we know the curve is positive only, right? Because modulus is there and x is always positive in 0 to 2 pi. Correct? Curve is positive only. We need this particular area. How do I get this area? First, 0 to pi mein, area is what? Area is either here because it is above x axis. 0 to 2 pi x mod sin x dx. And mod sin x changes its nature, right? 0 to pi mein, it will be simply sin x because sin x is positive. From pi to 2 pi, minus x sin x when sin x is negative. Yes or no? How do I solve this? How do I solve this? We know integration by parts, right? Minus x cos x plus sin x. That is the integral, right? Correct, students? पहले cos x का sin x का integration, that is minus cos x, minus of minus plus integral cos x, that is sin x. Correct, students? From 0 to pi, and इसका negative version is there, x cos x minus sin x from pi to 2 pi. Substitute. पहले pi substitute करेंगे, that will be pi into cos pi is minus 1. So overall pi it will be sin to 0 for both of them. And when it is 0, 0 plus, when we substitute 2 pi in this will be 2 pi. And when I substitute pi, I will get minus of minus pi, minus of plus, that will be plus pi. So answer is 4 pi. Is it clear, students? Students, is it clear?
Yes.
Yes.
Yeah, right now. Find area under y equal to ln x plus tan inverse x and between the lines x equal to 1, x equal to 2 and y equal to 0. Y equal to 0 is x axis. Basically, that's why I asked you under also. So how does the graph look like? So we are looking at x equal to 1 and x equal to 2 each way. And ln x plus tan inverse x. See, both are positive in this range. ln x is also positive. Tan inverse x is also positive from 1 to 2. So the graph is somewhat, actually 1 pay 0, but ln x, but that's fine. Overall, it is positive. So the graph is going to be somewhat increasing. Both are increasing curves also. X equal to 1 and x equal to 2. We want the area enclosed between them, right? Area enclosed between them is going to be this one. X equal to 1, x equal to 2, and y equal to ln x plus tan inverse x, and y equal to 0. Y equal to 0 is x axis. This particular portion of area. That is what area equal to integral 1 to 2 f of x dx. That is ln x plus tan inverse x dx. Can somebody tell me what is the log x ka derivative? X ln x, sorry, integration x ln x minus 1 minus x. And what is tan inverse x ka? Students, what is tan inverse x ka?
X tan inverse x minus 1 by 2 ln 1
plus x square.
Correct. X tan inverse x minus 1 by 2 ln 1 plus x square. Correct enough? Limits are from 1 to 2. So first we'll substitute 2 in it. I will get 2 ln 2 minus 2 plus 2 tan inverse 2 minus half ln 1 plus 2 square, that is ln 5. And we'll substitute 1 in it. What will I get? 1 ln 1, that is 0, minus 1, or minus of minus 1 plus 1. And minus 1 tan inverse 1 minus pi by 4. Tan inverse 1 is 45 degrees. And minus of minus plus half ln 2. 1 substitute करेंगे ln 2 आएगा. So half ln 2 plus 2 ln 2. 5 by 2 ln 2 plus 2 tan inverse 2 minus half ln 5 minus pi by 4 and 2 minus 2 plus 1. That will be minus 1. This is the answer. Please write it. Find area bounded by y equal to ln x base half. See, ln x base half is a decreasing curve. Okay, if I have to precisely tell you, y equal to log x base half, that you can write it as 2 power minus 1 minus log x base 2. Log x base 2 से minus multiply किया गया. The graph is going to be like this. A decreasing curve. Okay, log x base 2 का minus से multiply किया गया. And at x equal to 1, this is 0. And x equal to 2, it is going to be negative. Now we are interested in finding out the area between this from, actually I should give you y equal to 0 also, so that it will be more precise. Now from here to here, we need to find out the area. That is this portion wala. Correct, students? What is that area? Since it is below x-axis, it is going to be negative. So I need to multiply that with a minus. So area is already original, if one minus is there, we can multiply with one more minus to become log x base 2 from 1 to 2. What is log x base 2 ka integration? We can write it as 1 by ln 2 into 1 to 2 ln x dx, because log x base 2 we can write as ln x upon ln 2. Now we can integrate 1 by ln 2 into x ln x minus x from 1 to 2. That will give you 1 by ln 2, 2 ln 2 minus 2. X equal to 1 डालेंगे तो पहले वाला 0 है, minus of minus 1 plus 1. So 2 ln 2 minus 1 upon ln 2. Write it off for this. Area bounded by y equal to x cube, x equal to minus 2, x equal to 1. Now x cube graph will be what? We know how does the graph of x cube look like, right? It's going to be like this. And we are interested in area from minus 2 to 1. From minus 2 to 0, it is negative. Afterwards, it is positive. Correct now? So we have to write it like that. Area is minus 2 to 0 minus x cube dx का area चाहिए, and 0 to 1 x cube का dx. Correct, students? That is minus x raised to 4 upon 4. Limits are from minus 2 to 0 plus x raised to 4 upon 4 from 0 to 1. So this will give you 16 upon 4 plus 1 upon 4, 17 upon 4. That's your answer. Please write it down. Next heading is area with respect to y-axis. Integral x dy. See, why do we have to learn area with respect to y-axis? Yeah, in boards though, they will ask you specifically to find the area with respect to y-axis. That is one reason I can say. But in mains and advanced, you can actually find out any area with respect to x-axis as well. Kabhi it will be much more tougher than if you do area with respect to y-axis, but you can do. It's not an impossible task. Do you understand me, students? Area with respect to area towards, like matlab jo bhi area hai, you can calculate using x-axis also. For example, imagine you have the parabola like this, and which is known to you, y square equal to 4x less a, and a circle, x square plus y square equal to a square. If I ask you the area enclosed between them, how we actually calculate? Let me tell you. If you have to calculate area with respect to x-axis, what will you do is you will calculate this particular portion ka area under parabola. Okay, and you will calculate this particular portion ka area under circle. Matlab with respect to x-axis while I'm talking about. Okay, from this point, wherever they are intersecting from that point, then you will double it, because below x-axis and above x-axis both are symmetric with respect to x-axis, right? So below x-axis कितना area उतना numerator ऊपर भी है. So you will double the area. That's your answer. Sum of them into 2. That's a tedious task. Okay, because first you need to solve like anyhow. That is some part of it is obvious even if you integrate with respect to y-axis. But when it comes to integration with respect to y-axis, this is kind of single integral. That is, you will try to find out area under the circle. Sorry, area under the area under the circle. Correct. That is this entire portion. From this, you will remove this portion, area under the parabola. Basically, I'm saying here it is only one integral. There are two integrals. Do you know why? Limits here are same. In the earlier case, limits are not same. आप देखेंगे earlier case में the portion of this x coordinate इधर से इधर तक पहला इंटीग्रल है, इधर से इधर तक सेकंड इंटीग्रल है. So there are two integrals basically. Here limits are from here to here. The same limits, it will become single integral. Sometimes that will come to your advantage. Number one. And integrating with respect to y-axis is much better than integrating with respect to x-axis. In some questions. Is it clear? So you need to be versatile with both the cases. Clear, students?
Yes, sir.
Yes. Yes.
Now let me explain you how to find out integration with respect to y-axis. So imagine you have a curve y equal to f of x, and the curve is somewhat like this, and area with respect to y-axis. That means this particular portion ka area we are interested in. So it is completely on that side of y-axis. Okay. So this area, whatever the portion we are looking at, area from A to B. See, one more thing here, y equal to f of x nahi likhte hai. Okay. See, if you look at the structure of this integral, x dy, earlier it is y dx. Okay. So this I will write it as x equal to g of y. Generally क्या होता है, y equal to sin x रहता है. We don't integrate sin x. We are supposed to write x equal to sin को लेके जाओ in terms of y लाओ, x को in terms of y लाओ, उसको integrate करो. Do you understand, students?
Yes.
So area is integral. Instead of A to B, I will write. Okay, fine. Y1 to y2. That's better. Integral y1 to y2 g of y dy. Is it clear, students? Imagine if the curve is on this side of the curve, this side of y-axis. If the curve is like this, then how do we find out the area? So this is y1, this is y2. Here, in this case, area is integral y1 to y2 minus g of y dy. Samjhana, students?
Yes.
Just like in earlier case, imagine if it intersects the y-axis. Matlab, it is going to be like this. It is y1, it is y2, and beach mein y3 is there. So this portion as well as this portion, we need the area. So area in this case is going to be integral y1 to y3 minus g of y dy, because it is on that side of y-axis, plus y3 to y2 g of y dy. Is it clear?
Yes.
Please write it down. Find area enclosed by y equal to sin inverse x, y equal to 0, y equal to pi by 2, x equal to 0. Okay. So x equal to 0 is y axis, y equal to 0 is x axis, and y equal to pi by 2. Y equal to pi by 2 is this line. And sin inverse x. We know sin inverse x is going to be like this. But too much, I did it little extensively. It's going to be like this. Now we want area enclosed here. This particular portion ka area chahiye. Correct, students? How do we find it out? It is on positive side of y-axis only. Correct enough? This is y equal to sin inverse x. What should be my area? Area integral. Area should be equal to. Can somebody tell me what should be my area?
Sin y dy from 0 to pi by 2.
Correct. First of all, y values लिखना चाहिए. इधर से इधर तक y values. Y values are 0 से pi by 2 and x dy. पहले x लाना है इससे. X is sin y. Sin y dy. Integration will be cos y. Actually, integration sin y is minus cos y. Limits are from 0 to 90. 90 substitute करेंगे 0. Minus of minus cos 0. That is plus cos 0. That's all. Please write it down and try this. Find area enclosed by y equal to 4th root of x, y equal to 1, x equal to 0. Right. Y equal to 4th root of x. So graph will be somewhat similar to square root of x. It's going to be like this. And integration is from 0 to 1, y equal to 0. Sorry, x equal to 0 and y equal to 1. Y equal to 1. In तीनों के बीच में. So that is this portion of the graph. Yes or no? Now what are the limits? Y equal to 0 say, so area will be, it is positive side only, 0 to 1 and x dy. See, y is 4th root of x. X क्या होता है? Y raised to 4. Y raised to 4 dy. Integration is y raised to 5 upon 5 from 0 to 1. That is 1 upon 5. That's our answer. Please write. And those have done it, they can try this. Just a minute. There's an next question. Please try it. Let us, like, we know y equal to e raised to x the graph. That is pretty much famous. It's going to be like this. Increasing. And x equal to 0 is y-axis. And y equal to e. See, this is x equal to 0 पे 1 है. ये ये y equal to 1 है, y equal to e will be here somewhere. Area enclosed between these three, e raised to x, y equal to y equal to e, and x equal to 0. That is this portion. Correct? Now, area with respect to y-axis, right? As per rule book, area with respect to y-axis is what? That is integral lower limit y equal to 1 to y equal to e. See, y is e raised to x. हमें x लाना है. X is ln y. Correct ना? So ln y dy. Correct? As per rule book, this is the answer. So D is correct answer. Now we need to check whether other things are correct or not. Apply King's rule. If I apply King's rule, integral 1 to e, that will be what? Ln of 1 plus e minus y, right? Even B is also correct. Correct, friends? Let us look at C wala answer. Okay. Now C wala answer is also correct. Do you know why? I'll prove it. Observe it. I will draw a line like this. Okay. This is x equal to 1. X equal to 1 पे y value e है. Now this is 1 and this entire length is e. So what will I do is I'll try to find out area under x-axis. What is area under x-axis, students? Green wala portion area. Integral e raised to x from 0 to 1. X value 0 say 1 tak e raised to x hai. This is not what we need, but we are finding this out. Do you know why? Because I'm going to subtract that from the rectangle 0 to 1 e raised to x. I'm going to subtract this from the total rectangle area. Rectangle area is what? 1 into e. Base e minus integral 0 to 1 e raised to x. That is option C. Did you understand, students? And इसका evaluate करेंगे e minus, what is the evaluation of it? E raised to x is integration e minus 1. So e cancel, 1 is the answer. So this is wrong answer, first option. Do you understand, students? Please write it down.